So in this lesson, we are looking at the Fundamental Theorem of Algebra. And we are going to start with the vocabulary review. And we start with complex numbers. And the complex number system includes real and imaginary numbers. The standard form of a complex number is a plus bi. So a represents A and B are the real numbers. Remember, I represents the imaginary unit, which is the square root of -1. And just remember, I squared is -1. So according to the fundamental theorem of algebra, every complex polynomial function has a degree of degree 1 or larger has at least one complex zero. Okay, so what does this mean? So if I have an equation, let me give some equations, some examples here to illustrate this. So if I have x squared plus 3x plus 2, this equation has a degree of 2, so n is equals to 2. So this just means it's going to have two solutions. So two solutions. Remember, the solutions might be real or imaginary. I do not know. All I know, because the degree is 2, so it has two solutions. Some might be real, some might be imaginary. And some might repeat. For example, if I have x squared plus 6x plus 9 is equals to 0. This one I can get the solutions. So this is x plus 3 squared is equals to 0. So x is equals to -3. And the multiplicity is 2. So multiplicity is 2, which means it's a repeated solution. But just because I know the degree is 2, I know it has two solutions. And in the same way, if you have an equation with a degree of, let's say, 2x plus 2 is equals to 0, the degree is 1, so it has one solution. So the degree helps you to know how many solutions. However, you cannot tell whether they are real or imaginary. But when it says here has complex and complex zeros, what does that mean? It doesn't mean that all of them are going to be real. Remember, if I have this solution, for example, if I solve this one, I get x is equals to -1. Remember, I could write this solution as -1 plus 0i. So every real number can be expressed as a complex number. So only that the imaginary component is going to be missing. So here, let's check our understanding. According to the fundamental theorem of algebra, the polynomial below will have how many solutions? How do I know? So I just look at the degree. So the degree is 7. So I know it's going to have 7 solutions. But I do not know how those solutions look like. They might be repeated. They might be imaginary. They might be irrational. I do not know. All I know is that it has 7 solutions. Okay, let's look at another theorem which is helpful here when you're looking at the fundamental theorem of algebra, and it's called the Conjugate Pairs Theorem. And we have looked at conjugates before. So what does this rule say? If a plus b is a zero of a polynomial function and the coefficients are real numbers, then the complex conjugate is also a zero of the function. And how you can be able to tell this? Remember, when you solve an equation, let me give an example. An example usually helps. So if I have x squared minus 1 plus 1 is equals to 0. So this means that x squared is equals to 1. So that means x is minus 1 plus or minus square root of 1, -1, which is equals to square root of -1, which is equals to plus or minus I. So what we are saying here, whenever you have imaginary solutions or complex imaginary solutions, they occur in pairs. You cannot have one. In the same way, if I have something like, in the same way, if I have, so this is for the conjugates. You're going to see the same thing when we have x, let's assume I have x squared minus 2 is equals to 0. So x is going to be plus or minus square root of 2. In the same way, the radicals happen in pairs. You cannot just have one radical. So that's important. So here we have an example. A polynomial of degree has how many zeros? 2, 3 plus I. As its zeros, what is the other 0? So here we can, the other 0 is going to be the complex conjugate of that, which is going to be 3 plus I. So all the zeros now, so this is the missing, not 3 plus I, but 3 minus I, 3 minus I. So that's the answer. And remember, the other zeros are 3 plus I, the ones which we are given, and 2. So, and we know here the degree is equals to 3 because it has 3 zeros. And according to Fundamental Theorem of Algebra, we have 3 zeros. Okay. Now, let's go to the next one. A polynomial function has 5 of degree 5. Oh, that's important. Degree is 5. Has 4, 2 plus 3, and 5i. So what are the other zeros? So I know we are going to have 2 minus 3i, which is the conjugate of 2 plus I. And I know I have 5i, and I'm going to have negative 5i. And in the same way, you can see now we have 1, 2, 3, 4, 5. So the fundamental theorem of algebra helps us to find the zeros which are missing. Let's look at another example. A polynomial function of degree 4 has 2 with a 0 multiplicity of 2. And we are given 2i as its zeros. What are the other zeros? So we have 2, and this is repeated because it has a multiplicity of 2. We want to make sure we have 4 roots. And we have, what's the other one? Then we have the other one, which is 2 minus I. And what's the other 0? It's going to be 2 plus I. See, 1, 2, 3, 4. So here is what the question was asking. But you can see we have 4 roots. So the degree, it corresponds with the degree. Okay, now the next thing I want us to look at here is how to use the fundamental theorem of algebra to write the equation of the raised degree when we are given the root. And how can we be able to do that? So here we are told write the equation. Simplest equation of polynomial with the following roots. So here the polynomial is going to be, it's going to be x plus 1, x minus 2/3, and then x minus 4. So those are the roots. And then we just need to multiply. Okay, to multiply, I'm just going to take the first 2, and when I multiply them, I'm going to get x squared plus 1 over 3 x minus 2/3. And then I'm going to multiply that by x minus 4. And when I multiply those two, I'm going to get x cubed minus 11 over 3x squared minus 2x plus 8/3. So that's going to be the polynomial once we multiply out. And you always have to check what the question is asking. Is it asking you to leave it in factored form or multiply it out? Okay, here we have another equation. So we're going to write f of x is going to be x plus 2, x minus 2, and then x minus 4. Then when we multiply, we get x squared minus 4, x minus 4. So when we multiply this together, we get x cubed minus 4x squared minus 4x plus 16. So that's going to be the equation. Okay, now here we are given like the simplest function with the zeros, 2i, 1 plus square root of 2 and 3. Leave the answer in factored form. So we write the zeros, 2i. If I have 2i, then I have negative 2i. And then I also have, what else do I have? I have 1 plus square root of 2, which means I also have 1 minus square root of 2. And the next step is just to, step 2 is just to write the equations. And I also have 3. So I know this is going to be of degree 5. 1, 2, 3, 4, 5. And so in my next step, I'm just going to write the equation. And it's going to be f of x is going to be x. I will use brackets here, minus 2i. And then I'm going to have x minus, then I'll put parentheses here, negative. So this is going to be negative 2i. And then I'm going to have x minus 1 plus square root of 2. And then I'm going to have x minus, and then 1 minus square root of 2. And this one, we're just supposed to leave it in factored form. And of course, you can see it has so many steps to multiply it out, but that's how we're going to leave it. And let's go to the next one.